in our group, in our center, and we look for some group abroad, especially in Germany or in USA, that is working in similar issue, and I think that is a good idea because.
So what often happens with students here at Purdue is that they will begin their work doing theoretical things. So they'll do computer simulations to design a device and develop a process. And then later, as they work through their thesis, they will end up going into the laboratory, fabricating the device, making measurements. Actual device.
Yeah, yeah. It's difficult to say. Also, normally, most of these study ended finished only with some. Don't finish with some devices. That's the problem also. Because you have to do something. You need some equipment and so clean rooms and nanolithography. So we have, for example, in our center the possibility to do some nanolithography now. 3 years ago we don't have this possibility. Also, clean rooms is very important issue, or nanolithography or something like that. That reflects the idea in a theoretical prediction. But by sure, our students are well prepared. That is by sure. Also, only 1 year in a very good center, as I will show you tomorrow, our student can produce a lot of things because it's well prepared. That is very important. Monica.
I noticed you have a relationship with UNAM. Can you say a little bit about that and which one of your 4 core areas has a relationship with UNAM?
With?
UNAM? There was UNAM, Universidad de México?
UNAM.
Relationship with UNAM.
So with the Institute of Material of UNAM in Mexico, with Professor Roberto Escudero, we do a lot of work on GMR, gallium magnetoresistant in oxides. At that time, we produced multi-layer or lanthan, calcium manganite, ferro antiferro, and we did a lot of work with Roberto Escudero, also in Ensenada with Jesus Eiras. So we have a long-term collaboration with Roberto Escudero's group at UNAM and Eiras at Ensenada.
Do you have any collaborations with Argonne or anywhere else where you have an opportunity to use remote instrumentation?
Yeah, with Argonne we have a very strong collaboration with the group of Axel Hoffman at Argonne National Lab. So we send our 3 PhD students visit Argonne for 1 year. We have collaborative publication with Axel Hoffman and Sam Bader on people from Argonne National Lab. That was a good idea you have in your world, this collaboration. So I will try to do the same. And this is a good form to show the different collaboration with Argonne and in Argonne National Lab, and also with Orlando Uccello. We send students for, in this case, 1 year and 6 months, and they finish his PhD by doing something, by taking the sample from our lab and doing the measurement in Argonne National Lab. Yeah.
What is your funding structure for research look like? Is it mostly from the government or the industry?
Good question. As usual in our country, the industry give no money. This is very difficult. It's also here, but there is almost impossible. So the financial support comes from our National Science Foundation that is called Ciencias. The question is, how much is the investment in this center. In the last 5 years, more or less $4 million. This is not a big deal, but this is the more important issue in this center is a long-term project. It's not a research project that takes 1 year. This is a long-term project, 5 years. So we have spent more than $4 million in equipment, payment the students, mobility or something like that. But most of them is from the government. There are some support from industry through collaboration, but short-term collaboration. And also, normally the industry doesn't pay money. They send an engineer or they make something like that. But money, no, it's not the case. It's what we are trying to do, but it's difficult. It's very difficult. Yeah.
So what kind of sensor are you working on?
What kind of sensor? Also, what I have to show is the vanadium oxides as smart windows. This is one possibility. The other thing is by using lanthanum manganite, we have produced GMR sensor. That means device that responds to the magnetic field by using multi-layers. This is more or less the type of sensor we are producing, also a magnetic sensor. We have also worked with ferroelectric material as capacitor, but it's not really a sensor.
As a director of the CENM, I guess you have had the opportunity to interact with other researchers in other countries.
Mm-hmm.
Can you please comment on what is your view on the state of the research in nanotechnology for Latin America?
Oh, okay. Last year, I was invited to the April meeting from the American Physical Society in Denver to present an overview of the nano initiative in Latin America. Also, the situation is quite disappointment. There's very low investment in. There is only nano investment in. Also, and as you know, for nanotechnology, you need mega investment. Also, I made an analysis of all of the countries in Latin America. Also, only Brazil have a very good nano program, a very good one. Something in Argentina, but Chile started with two centers, one in Valparaíso, another in Santiago, and it's nothing more. And in Colombia, our center, no more. So you cannot take not much time to look what is happening. It's nothing. It's very low, very, very low. Also, that is really something that our government need to take care of. So, nanotechnology is a technology that have a lot of possibility in nano agriculture, nano agri-food, medicine, or something like that. But they say, this is too much to invest, or this center is something rare in Colombia, in Latin America. So an investment for $4 or $5 million. That is. Yeah, please.
In the presentation, there was mention of a smart window. So what's the functionality of this smart window? Does it change the reflectivity?
Yeah. In this vanadium oxide is a very strange material. Make a structural transition at above room temperature, 60. Also, it's not only electrical, but this is optical too. Also, they change the reflectivity for this at this transition, and that is a possibility to to make this material as some so-called smart windows to control the heat transfer through the window. This is one possibility. Another possibility of this material is for using as random access memory too, but it's more complicated. Using this transition, but the more the great possibility in this is by using this as using this transition, but this is an optical transition. The reflectivity change in some order of magnitude is quite high.